Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tear, and this is my continuing feature on the Math Lovers book. And I'm up to section 3.2, which is on irrational numbers, and now I'm talking about square roots. Yesterday, I said what square roots are, and that they're a type of irrational number as long as the thing inside the radical is not a perfect square. So now, today, I'm going to prove that the square root of 2 is an irrational number. As a matter of fact, you can use a very similar proof to prove that the square root of n is irrational when n is any positive integer that's not a perfect square. So anyway, let's begin. And I have another video on this, by the way, which goes into more detail. This is going to be a very short video. I'm just going to explain this proof, which is really just one page long. And this is a very old proof, by the way. It's believed that the Greeks proved this. I think it's the legend, at least, is that there was a Greek named Hippasus who was the first to prove that the square root of 2 was irrational. But it was such a shocking result that supposedly the Greeks had him drowned at sea for this. The Pythagoreans. He belonged to Pythagorean school, and I guess the Pythagoreans didn't want to believe in irrational numbers. But they do exist, and the square root of 2 is probably the easiest irrational number to prove that's irrational. So how do we prove it? Well, this is what's called a proof by contradiction. We're going to assume the opposite. We're going to assume that square root of 2 is a rational number. Well, if it's rational, we have to be able to write it as a fraction of two integers. So let's write it as p divided by q, p over q if you like. And that means if you multiply both sides by q, you get p equals q times the square root of 2. If you square both sides, you get p squared equals 2 times q squared. But that means that p squared is even because it's divisible by 2. But if the square of a number is even, that means the number itself has to be even. That means that p is even. But then if p is even, then its square has to be divisible by 4 because the square of every even number is divisible by 4. You can check that yourself, and it's pretty easy to prove. Anyway, but now, if remember the p squared was equal to 2 times q squared, well, we have 2 times q squared as a multiple of 4. But the only way that can happen is if q squared itself is a multiple of 2. But that implies that q squared is even, which implies that q is even. But now we have a contradiction because we just proved that both p and q have to be even. But that means that this is not a reduced fraction. The other thing I forgot to mention, we were assuming this is a reduced fraction. If it wasn't, we could always reduce it. We could divide both p and q by their greatest common divisor and make it into a reduced fraction. But since we get a fraction that's not reduced, then that's a contradiction. So that's the proof, basically, that the square root of 2 is irrational. Pretty simple proof. And it's an example of what's called a proof by contradiction. And these are very common proofs. I think I gave another proof by contradiction, if I'm not mistaken, earlier in going over the Math Lovers book. I'm pretty sure I don't remember offhand which one it was. I haven't proven too many things yet. I think I did give a very simple visual proof of the Pythagorean theorem. Oh, I remember what it was. The Pythagorean theorem was not a proof by contradiction. That was a proof without words that used pictures, a very simple pictorial proof. But I also, oh yeah, I remember what it was now. It was Euclid's proof that there are infinitely many primes. That also involves a simple proof by contradiction. So, very powerful tool for proving things. Even the Greeks knew how to do proofs by contradiction. The Greeks were pretty good with logic, by the way. As a matter of fact, I'd say that was the ancient Greeks' forte. And as far as I know, I think the ancient Greeks were the first culture in the world to do proofs and to use what's called logic. And I think I did a bio on Aristotle. Aristotle introduced the logical syllogism, which was kind of the beginning of mathematical logic. So Greeks had a lot of advanced math, but they didn't believe in irrational numbers. The other problem was they didn't have the concept of zero or infinity, which is ultimately why they could never discover calculus. But they did pretty good for their day, I'd say. Anyway, so that was just another thing the Greeks proved that the square root of 2 is irrational. Anyway, that completes my video for today on the proof of the irrationality of the square root of 2. Thank you for watching. Long live math, and I'll see you guys next time. Bye.